Here's some advice and reminders about problem solving with quadratics. I'm going to use my calculator through most of this activity, this assignment, and I'm going to start by entering the equation in y equals 2x squared plus 4x minus 6 in order to answer all the questions in number 1 about it. Just a reminder that the zeros of a parabola are the x-intercepts, where the parabola hits the x-axis. That'll help with A. The vertex of the parabola is going to be either a maximum or a minimum, which we can look for in the table, and since the A value here is 2, our parabola is going to open up, so we're looking for a minimum value in our table. And part C, the points where the parabola reaches a height of y equals 10, that's going to be easy. I'll look in my table. That probably happens twice. And then I will have to use pencil and paper to write the equation of the parabola in vertex form, and I can show you real quick what factored form is. We haven't been working with factored, and I won't assess you on that, but I'll show you. We can sketch our parabola. As soon as we have all this information, it's going to be easy to make a quick little sketch of it. So once I have the equation in y equals, I can go second graph and look at my table. And my table was actually set because I had looked at this before I started my video. So scroll around in your table and pause the movie if you have to. Pause my cool movie. Pause the video if you have to in order to set your table at the place where you can see the vertex and the symmetry in the table. I actually see the zeros as well. The x-intercepts have a y value of 0. It means they sit on the x-axis, so they don't move up and down. And the zeros I see are 3 and 1 for x values. Oops, negative 3 and 1. Negative 3 and 1. The vertex of the parabola, the minimum value, is at negative 1 and negative 8. Means my axis of symmetry would be a vertical line, x equals negative 1. And then when does the parabola reach a height of y equals 10? Interestingly enough, it fits in my window here, but I'm seeing that at negative 4 for x and 2. So we've got some symmetric points there, negative 4 comma 10 and 2 comma 10. Oops, almost in the parentheses, that's all right. I'm going to come back to writing the equation. I'm going to do a quick sketch of the parabola, and I'm not going to do that on graph paper. I'm going to fold my paper upwards. And in my sketch, I'm going to label all the relative information we have. So set up your x and y axis, and let's start by putting a point at the approximate place where the vertex would be. Negative 1, and I got to go down to negative 8. I'm going to extend this just a hair. I'm not going to put numbers, but I will put little estimated tick marks here. 2, 3, 4, 5, 6, 7, 8. Well, I was down there. This parabola is going to go open upwards. I know that because the A value is 2. So there's my vertex. I'm going to label it vertex. It is negative 1 comma negative 8, since this is not a great piece of graph paper. This is hitting the x-axis at negative 3 and 1. Well, this sketch is going to turn out all right. Oh, I have a y values of 10. That's going to get up pretty high on the y-axis. Ooh, I'll use something else. How about the c value? It tells me that it is going to hit the y-axis at negative 6. 1, 2, 3. That C was negative 6, and it told me it was going to hit there. Now I have a nice sketch. Not even on graph paper. I didn't mean to look at it on my calculator either. So I left behind part D, the equation of the parabola in vertex form, y equals a times x minus h squared plus k. And in order to put it into vertex form, I need a couple things. I actually know A. We already talked about it. The A in standard form is the A in vertex form, and then the h and the k we actually found as well. The h is negative 1, and the k is negative 8. So in order to put it in vertex form, I'm going to replace the a with 2. X plus 1 in parentheses squared, and then minus 8 because that was a negative 8. Now, in factored form, I can show you what factored form would look like. Y equals, I'm going to go back to my standard form of this, and what I'm going to do is try to figure out what would have resulted for me to have 2x, or would have been the factors, the binomials on the outside of the box, for me to get these results. And I'm going to try a couple things. I think I'm going to use x and 2x here. That would give me my 2x squared. I'm pretty sure about that. In order to get my -6 down here, I have to have either a -3, oh, there's a couple options, and a +2. Let's see if that would work for me. This would be -3x, this would be 4x, and that would not result in that. I'm going to have to move my numbers around and try something different. Maybe put -2 and +3 here. This looks like it might work. 3 times 2x is going to give me 6x, and -2 times x is going to give me -2x. There's my 4x. So factored form for this would be undoing our boxes and using area model in this case. I found this. That was a cool little add-on. You're not going to be assessed on that. You'll study more about factoring and practice more in Algebra 2. On the rest of this assignment, I want you to pay attention to what the question's asking for. Is it looking for zeros or x-intercepts? Let's see here. In number 2, when you read that question, the effectiveness, this is looking for x-intercepts when the y value is 0. Maximum, you're going to need to have to find the vertex. And you're going to look for when, and probably in 2 places. Let's see, this opens down. You had 80% effectiveness. In number 3, looking for places when the height reaches 10. That reminds me of number 1. And using those ideas to solve the rest of the problems. Draw pictures if you need to. But persist in solving these problems. You've got the skills that it takes in terms of finding, is it the x-intercepts, the y-intercepts, the minimums, the maximums, and you can convert from from standard form into vertex form to help answer questions if you need to. Good luck.